In this video, I want to show the steps to solve a rational inequality. The inequality is given as x squared plus 5x divided by x squared minus 9 less than or equals to 0. So the first step, we want to rearrange the inequality in standard form. In other words, we want to have one side of inequality being 0. In this case, it is already in standard form. Really, we don't have to do anything about it. Yeah, we start with this, and then we're going to determine what we call the boundary points. When we solve irrational inequalities, boundary points include zeros of the left-hand side rational function and the x values where the rational functions are not defined. Let's start with the zeros. So we can determine the zeros of the rational function from the zeros of the numerator. In this case, it's not hard to find out that the zeros are going to be 0 and -5 if we factorize the numerator. So as long as these two numbers doesn't make the denominator being 0, then these two zeros of the numerator are going to be 0 of the rational function. In this case, none of them will make the denominator equal 0. So these are the zeros. So next, we're going to determine the undefined x values. In other words, we're going to find the x values such that the denominator is going to be equal 0. So we set the denominator equals 0. This gives us one x being 3, the other x being -3. So these are the two numbers where the rational function is not defined. Okay. So with these boundary points, we're ready to draw the sign chart across the entire real line. Think of this line as a real line here. I'm going to separate this entire line into several intervals divided by these boundary points, including the zeros and the undefined x values. So if I have a 0 on top of this line, that indicates this number is a 0 of the rational function. If I have a circle at this location, that indicates at this point the function is not defined. Okay. So if we're going to do this using the test point, because we know over each of these intervals, the sign of the rational function is going to be the same, either positive or negative. It's never going to do a change of sign, okay, by intermediate value theorem. So, for example, over the interval from -infinity to -5, we can choose any number to determine the sign of it. Let's pick the text number being -6. But you can do -7, -8, -10, as long as it is within this interval, then we're good. So if we do a direct substitution to the left-hand side rational function, and then evaluate the function at that number, eventually the sign at that number is going to be the sign of this entire interval. Okay, it turns out to be positive. Similarly, we can do it for the remaining intervals by picking a test point like this, but you're free to choose your own test points as long as it is within the interval. So the other way to do it is if the left-hand side function seems to be complicated to evaluate directly, we can go with the sign of the factors at the top and the bottom. So at the top, we have the factor being x and x plus 5. And at the bottom, we have the factors being x plus 3 or x minus 3. So we're going to determine the sign at each of these factors. Well, x is -6, x is negative, x plus 5 is negative, x minus 3 is negative, x plus 3 is negative. So eventually, the sign of all these factors is going to determine the sign of this entire rational function. So the rules to determine the sign with regards to multiplication and division are the same. If two negatives get multiplied with each other or divided into each other, it will turn to a positive. In other words, any two negatives, if they get to pair up, you'll get a positive. So I do have uh, four negatives here. So any two of them will change to a positive. So eventually it's going to be positive. So similarly, we'll be able to determine the sign of the rational function by determining the sign of all of these factors, and then eventually, based on the sign of the factor, determine the sign of the left-hand side function. So this is what the sign distribution looks like. It changed from positive to negative, and then to positive. So based on the sign chart, we'll be able to write down the solution for our inequality. In this case, we're looking for x values such that the left-hand side rational function is less than or equals to 0. So we're looking for the negative intervals. That's going to be the interval from -5 to -3 and from 0 to 3. But we have to be careful about endpoints. Since we're dealing with a non-strict inequality, so we're going to include the zeros as well. -5 is 0 and 0 is a 0. So we do have to use the square bracket for these two endpoints to indicate these two numbers are part of the solution. But -3 and 3 are not, because these two numbers are where the function are not defined. So eventually you want to connect these intervals using the union sign to indicate it's going to be a combination of these two for our solution.